Hey guys, welcome to Simply Electrical. This is my deep dive series where I take a slow and methodical approach and go through every step and give you every code reference for a single family dwelling service calculation. This is the standard method, and we'll be dealing with Articles 220, Sections 40, 42, 50 through 54, 56, and 60. If you're looking for something a little less involved, I do have another series, my crash course series, and that's basically just a bunch of examples of this very same method, and we just keep adding a couple of things, a couple of different loads for each example to try to, simulate what you might find in the field or maybe on a test. So please check out in the description. I'll have a link for both the crash course series and some other deep dives that I have on the other methods. I developed this table with the goal in mind of providing an overall picture on one page of the whole process. The whole calculation is right in front of your eyes here on one page. That way you don't have to flip back and forth between your figures and your different sections. So I've got it in 4 columns. I've got the lighting column, the appliances, the dryer and range, and the heating and cooling. And you'll see how I broke these up as we go through it. You'll understand why it makes sense to break them up this way. For your lighting, you're just going to have your square footage and your small appliances, laundry, all that stuff that goes under the general lighting demand. We'll take our demand factor and get a lighting total. And don't worry if I'm going too fast right now, because this is just a brief overview, and then we're going to get into the nitty-gritty and all the specifics in just a moment. Next, you have your appliance column where you just list your appliances and tally them up, get your total, and with some provisions we'll talk about later. Dryer and range. Take your dryer, get that in your range, get that total, and total them up. And then you got your heating and cooling, which is the first section of this column, and you total those up, figure out which one you're going to use. Then you have your largest motor, which is its own situation, and we'll have to treat that separately, and we'll have some discussion on how to do that and when. And you tally up your loads, get your heating total. Once you're done, you total up all 4 columns, and you get your total watts or VA of your dwelling. Once you do that, you divide by your voltage, normally 240 volt single phase, to get your amps. Then you can size your service. I have some notes down here about the table, but we'll discuss those points later on when we get to that section. We're going to take a very simple example, and then we're going to work through it as we go, and we'll explain each step along the way. So here we have a 1900 square foot house, has the 1300 watt dishwasher, a 4500 watt water heater, an 1100 watt disposal, a 10,000 watt range, 4800 watt dryer, 12 kW furnace, and a 6500 watt heat pump. The service from the street is 120 240 volt single phase. What is the total calculated service load in amps? Well, the first thing we do, we're going to start on the left side of the table. We're going to take our lighting column. We take our square footage of our single family dwelling, and we multiply that by 3 to get our VA total. Now, how do we know that? Well, 220.14J tells us. Let's read it. Dwelling units. In one family, two family, and multifamily dwellings, the minimum unit load shall be not less than 3 VA per square foot. So that's where we get the 3 VA per square foot. Take our square footage, multiply by 3, we get our total lighting load for this minimum unit load. That's 5,700, because we had 1,900 square feet times 3 is 5,700 VA. Now let's read on. The lighting and receptacle outlets specified in 220.14J 1, 2, and 3 are included in the minimum unit load. So what is that? Down here we got 1, 2, and 3. And these are the loads that are included in the minimum unit load. So it says all general use receptacle outlets of 20 amps or less, including receptacles connected to the circuits in 21011C3, which are the bath receptacles, and 21011C4, which are the garage receptacles. So those are included. Also, the receptacle outlet specified in 21052E, which are outdoor receptacles, and G, which are basement, garage, and accessory building receptacles, those are also included. And lastly, the lighting outlet specified in 210.70, which basically is all the lighting outlets in your house. So all of that is included in this number, so that's all figured in. It says no additional load calculations shall be required for such outlets. So we don't need to go and put these anywhere else in the calculation because it's already worked into this number. Next sentence says the minimum lighting load shall be determined using the minimum unit load and the floor area as determined in 220.11 for dwelling occupancies. So this is telling you where to go to find out how to figure your square footage, your floor area, and that is 220.11. We see that down here. And this says the floor area for each floor shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. For dwelling units, which is what we're talking about, the calculated floor area shall not include open porches, garages, or unused or unfinished spaces not adaptable for future use. Okay, so that's pretty easy, pretty self-explanatory. Last thing it says here, it says motors rated less than 1/8 horsepower and connected to a lighting circuit shall be considered part of the minimum lighting load. So again, the last thing that's included in this minimum lighting load is any motors that are rated 1/8 horsepower or less and connected to a lighting circuit. Okay, so that explains everything about this first step in this lighting column. We took our square footage, 1900, multiplied by 3, we get 5700. Next step is our small appliances. We have a 2-circuit minimum at 1500 volt amps a piece. How do we know that? Well, 220.52a tells us. Let's go to 220.52. This is small appliance and laundry loads for a dwelling unit. Small appliance circuit load. In each dwelling unit, the load shall be calculated at 1500 volt amperes. That's where we got this. For each 2-wire small appliance branch circuit as covered by 210.11c1. 210.11c1. That is right here. Dwelling units. Small appliance branch circuits, that's what we're talking about. In addition to the number of branch circuits required by other parts of this section, 2 or more 20 amp small appliance branch circuits shall be provided for all reciprocal outlets specified by 210.52b. So it's referring us again to another code. Go down to 210.52b. But first, let's get what they're saying here. This is saying, in addition to any other requirements they've already talked about, or haven't yet in the code, we must put at least 2 20 amp small appliance circuits in this figure, in this calculation. So then it references which ones by 210.52b. And this tells us, under small appliances, reciprocal outlets served. So in the kitchen, pantry, breakfast room, dining room, or a similar area of a dwelling unit, the 2 or more 20 amp small appliance circuits, which we're talking about here, required by 210.11c1, shall serve all wall and floor reciprocal outlets covered in 210.52a, all countertop outlets covered by 210.52c, and reciprocal outlets for refrigeration equipment. So, but it basically is saying any kitchen area and area that is closely related to a kitchen, those outlets, those receptacle outlets, are to be on this circuit. Now there is an exception to that rule, and we'll talk about that right here. It says the individual branch circuit permitted by 210.52b1, exception number 2, shall be permitted to be excluded from the calculation required by 220.52. Okay, so 210.52b1, what that says, well, the exception number 2, what that says is it allows for specific receptacles in the kitchen area to not have to be worked in with this calculation here for this small appliance load. Like if you have say a countertop microwave, that's part of, that would be covered under here generally, but with the exception, it tells us we don't need to figure that in if it's on its own circuit. It can be fed by another circuit that's not part of the small appliance circuit load. Or say you have under cabinet lighting that plugs in. Those outlets can be run off of a lighting circuit, and they don't have to be on this small appliance circuit. So there are a couple of exceptions to all of these loads required to be on this small appliance circuit. If that is unclear at all, please let me know in the comments. We can discuss that. I can make a video if we need to on exactly what loads that includes. Okay, the next sentence says where the load is subdivided through 2 or more feeders, the calculated load for each shall include not less than 1500 volt amperes for each 2-wire small appliance branch circuit. So that's pretty self-explanatory. That says even if it's split up between 2 or more feeders feeding your kitchen area, if your small appliance loads are split between 2 or more feeders, any circuit has to be at least 1500 volt amperes. You got to calculate that for every 2-wire small branch or small appliance branch circuit. So that's pretty straightforward. Then it says these loads shall be permitted to be included with the general lighting load and subjected to the demand factors provided in table 22042. Okay, we'll be talking about these demand factors in just a bit. But this load, the small appliance circuit load, it says shall be permitted to be included with the general lighting load. If you look over here real quick, this subtotal we're going to come up with, this is your general lighting load, this total. And so what that's telling us is our small appliance circuit load together with our laundry load, which we'll talk about in just a minute, combined with our square footage with our minimum unit load from 22014, we add these together to get our general lighting load. So it's just telling us here that this can be included in this calculation. You can take these at 100% if you want, but it's permitted to be included in this calculation and therefore can have this demand factor applied to it later on. That'll make more sense as we get further along. Just to recap for this line here, our small appliance circuits, we have 2 minimum at 1500 volt amperes apiece, so that's going to be 3000. That's your minimum value here is 3000. Now if you have more than those 2 that are required, you might have 3 or 4 if it's a big kitchen. Then this would be 4500 or 6000 even, depending on how many small appliance circuits you have. But you're going to have a minimum of 2 of these. So your 3000 is going to be your minimum number here. So let's move on to the laundry. And that is a minimum of 1 circuit is required at 1500 volt amps each. And 220.52b tells us that. So let's go down here to B, laundry circuit load. A load of not less than 1500 volt amps shall be included for each 2-wire laundry branch circuit installed as covered by 210.11c2. Okay, well that points us up here. 210.11c2 is laundry branch circuits. In addition to the number of branch circuits required by other parts of this section, at least 1 additional 20 amp branch circuit shall be provided to supply the laundry receptacle outlet or outlets required by 210.52f. This circuit shall have no other outlets. Okay, 210.52f down here. Laundry areas. In dwelling units, at least 1 receptacle outlet shall be installed in areas designated for the installation of laundry equipment. So that's the requirement right there, that every dwelling unit is required to have one receptacle outlet for laundry. Now there's an exception when it comes to multifamily, but since we're dealing with single family dwelling here, this does apply. So we have to put this laundry circuit in here. So this is telling us, because of that requirement, this is saying we have to figure that into our calculation. At least 1 additional 20 amp branch circuit. Now it says this circuit shall have no other outlets. That means we just can't put anything else on this circuit. Now we used to be able to, in fact we did this quite often, if there was another outlet in the laundry room, we just jump off the washer circuit and run to the adjacent wall or whatever and put an outlet there. Some people would oftentimes use it as an ironing outlet. And that was fine, it worked fine, but now they put this sentence in here that says no other outlets are allowed on this circuit, so we can't do that anymore. Okay, so that tells us that we need at least 1 circuit, the 1 minimum right here, and that it was 1500 volt amperes each, minimum. So let's read on. It says this load shall be permitted to be included with the general lighting load and shall be subjected to the demand factors provided in table 220.42. So the exact same sentence as we saw up here for small appliances. Laundry also is permitted to be included in this calculation here. So we take our 1500 volt amps, because we have our one minimum, and then we add these three figures up. We add them together, we get 10,200 total volt amps or subtotal volt amps. And that is our general lighting load. Now, because they know that we're not going to be using all these loads all simultaneously, the chances are very slim that we'll be using even half of these at the same time. They allow us to apply demand factors to this number. So we don't have to take this full 10,200 volt amps and put that into our overall calc. We can apply a percentage to this number, or it's actually a more complex calculation than just a percentage, and I'll show you in just a minute. We are permitted to take the first 3,000 at 100% and then take a percentage of the remainder. And let's figure out what I'm talking about here and why. Let's go to 220.40 first. Now, this is the beginning of part 3, feeder and service load calculations. This is the start of the standard method for calculations in the codebook. 220.40, okay, this is the general rule. So you're going to have the general rule, and then you'll have some other caveats and exceptions and permissions built in later. But the general rule is the calculated load of a feeder or service shall not be less than the sum of the loads on the branch circuits supplied, as determined by part 2 of this article, after any applicable demand factors permitted by part 3 or 4 or required by part 5 have been applied. Okay, so that's the general rule. We just take the sum of all the loads, add them up, and we come up with our total. But there are some exceptions we'll find out down here in just a second. First, let's talk about this informational note. It tells us to see examples D1A through D10 in the informative Annex D. That gives you a handful of examples of service calculations, and those can be very helpful. However, I've found that the helpfulness of them is a little limited because they don't really explain what they're doing, so it kind of leaves you wondering how they got to where they got with their figures. But at least you can get an idea of what's going on sometimes. So check those out and see if those will be helpful for you. Also, it tells us see 220.18b for the maximum load in amperes permitted for lighting units operating at less than 100% power factor. So, and that basically is just telling you that if you're dealing with nonlinear loads, loads with any kind of power factor, then you've got to include the entire load. You can't just add up the lamps, the bulbs, like you could like with incandescent. But if you have LED where there's a driver or fluorescent with a ballast, you got to add all that in there as the load. Okay, 220.42, general lighting. The demand factor specified in table 220.42 shall apply to that portion of the total branch circuit load calculated for general illumination. They shall not be applied in determining the number of branch circuits for general illumination. Okay, let's take the last one first. It just says these cannot be applied in determining the number of branch circuits. You don't go to this table over here to figure out how many branch circuits you're actually going to have. That is determined differently, and that's a different subject because we're dealing with the service calculation, not branch circuits. So this first sentence, back to this, it says the demand factors specified in table 220.42, which is over here, shall apply for general illumination. Let's go take a look at this table. It says lighting load demand factors. And just real quickly, anytime it says demand factor, all that means is it's a percentage of the whole. So you're taking a percentage of the whole, and that's what's required here. Instead of, like I said, instead of tallying all these up and getting 100% and just taking that, we're actually able to apply a demand factor to it, and we'll end up applying a smaller number than that. This table says portion of lighting load to which demand factor applies. We've got several types of occupancy here. We've got dwelling units, hotels, motels, apartments, warehouses, and everything else. We're just going to deal with dwelling units in this video, so I'm not going to talk about the rest of this here. And another side note, I wrote myself a little note here in my code book that says include small appliances and laundry. Remember, we just talked about that on the last slide, how there was a sentence at the end of each of those sections that said both small appliance and laundry circuits are allowed to be included in this general lighting load calculation. And I just wrote this here as a reminder to myself that those are included with this demand factor. So this demand factor we're going to figure out here applies to these as well, which is what we're going to do here. Okay, so it says under dwelling units, you take the first 3,000 volt amps of our general lighting load and apply 100% to it. So we take 3,000 off of this and write 3,000 right there, and we'll take that at 100%. And then anything after that, up to 120,000, we take it 35%. So the next 117,000, we take it 35%. Now, if we have something beyond that, like if we have a mega huge house, or we're dealing with multifamily, we may go beyond 120,000, and anything over 120,000 we would take at 25%, which I show here. Now that's pretty rare. You're hardly ever going to use that unless you are doing multifamily. So on this calculation on a single family, I doubt you'll ever run across a house that's that big. I mean, you're talking a mansion that is just loaded with small appliances and laundry circuits and just ginormous square footage. So anyway, most of the time you're going to have 3,000 here, and then you're going to have 35% of whatever's left over. And in our case, we take 3,000 away from this, we get what, 7,200? 35% of 7,200 is 2,520. So then we add the 3,000 and the 2,520 together, and we end up with 5,520 as our lighting total. And that takes care of column 1, lighting. Moving to the next column, appliances. Now these are fixed appliances. We're not talking blenders and toasters and curling irons and such like that. We're talking appliances that are fixed in place. And these are discussed under 220.53. So let's go straight there. 220.53, appliance load for dwelling units. It shall be permissible to apply a demand factor of 75% to the nameplate rating load of 4 or more appliances rated 1/4 horsepower or greater, or 500 watts or greater, that are fastened in place and that are served by the same feeder or service in a 1-family, 2-family, or multifamily dwelling. This demand factor shall not apply to household electric cooking equipment that is fastened in place, clothes dryers, space heating equipment, or air conditioning equipment. So a lot of times these things would fall under the appliance category, but they're saying in this case we do not include them as an appliance because they have their own special section. See, dryer, range, and heating, cooling. They have their own special section how they get calculated. So we're not talking about those. We're talking about anything other than those. And it says we can apply a demand factor of 75% to anything 4 or more. So what that means is we total up our appliances. We just list them here, 1, 2, 3, 4, 5, or however many we have. And we just write out their nameplate rating of volt amps or watts and list that here. And then we just add them up. Now, if there happens to be 3 or less, everything is 100%. So if it's 3 or less, everything's at 100%. We would put that value right there. Now, if there's 4 or more, then you take everything at 75%, except these. Anything less than 1/4 horse or less than 500 watts, that still has to be at 100%. That's what we find in this shaded area right here. So anything that's 1/4 horse or 500 watts and less and fastened in place, that's always got to be 100%. No matter if you have 50 of those, they still have to be 100%. But beyond that, we'll take the 75% if it's 4 or more. Okay, then you just add everything up. You take the percentage, whether it's 100 for 3 or less, or 75% of it for 4 or more, and you put that total right there. And that is your appliance total. So to see this in action, we've got our dishwasher, 1,300, water heater, 4,500, disposal, 1,100. Add those together, 6,900, it's 3 or less, so we take 100% of it, 6,900 is our total. If we had had one more appliance, say an InstaHot, we'd add that to it and then it would take 75% of everything. But we don't, so everything's 100%, 6,900 is our appliance total for this example. Third column is dryer and range. So we'll take the dryer first. We go to 220.54 for electric clothes dryers in dwelling unit. It says the load for household electric clothes dryers in a dwelling unit or units shall be either 5,000 watts or voltamps or the nameplate rating, whichever is larger, for each dryer served. So that means the dryer is 5,000 watt minimum. If the nameplate is over 5,000, you take the nameplate rating. Simple as that. So it's actually really easy. Next sentence says, the use of the demand factors in table 220.54 shall be permitted. Okay, so 220.54, demand factors for household electric clothes dryers. What you're seeing here is, depending on how many dryers you have in the household, you can take a demand factor. Now the first 4 are all at 100%, so you get no demand factor applied at all. So most houses, you're not going to worry about this chart at all because very few houses even have 2 dryers, much less 5, because you'd have to have 5 in order to get your first break and demand factor. So if you did have 5 though, or if it's multifamily, you'd be able to take 85% of the total. So you'd add them all up. If they're 5,000 or less, you put 5,000, add all that up, and take 85% of it. If the nameplate of each dryer, let's say it's 5,200, then you'd add 5,200 times 5 and then take 85% of that. So that's pretty straightforward. This is a really easy table to use. But like I said, we're doing single family dwellings, so it's unlikely we're going to need this table at all. Next sentence here says where 2 or more single-phase dryers are supplied by a 3-phase, 4-wire feeder or service, the total load shall be calculated on the basis of twice the maximum number connected between any 2 phases. I am not going to spend any time on this because that is almost only for multifamily. 3-phase service to a residence is extremely rare, so I'm not even going to deal with that here. I do go over this though on my multifamily calculation, so please feel free to check that out in another video. Last thing it says here is kVA shall be considered equivalent with kW for loads calculated in this section. So watts or voltamps, they're treating them as equivalent. And actually that goes the same for all these calculations. VA versus watts, you're going to come out with the same number no matter what you call it in a service load calc. So you'll see like in your appliances, they're all rated in watts. Pretty much any appliance you pick up and look at the nameplate of, it's going to be in watts. Well, just use that as your VA figure because it's going to be the same. Okay, so we got 5,000 as our dryer total because our dryer in the question was under 5,000. All right, moving on to the range. 220.55 covers electric cooking appliances in dwelling units and also household cooking appliances used in instructional programs. But we're dealing with dwelling units in this one, so we'll focus on that. It says the load for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances individually rated in excess of 1 3/4 kW shall be permitted to be calculated in accordance with table 220.55. Again, they make a comment here that voltamps and watts are treated as equivalent in range calculation. So let's go to table 220.55. This is a table that is often perplexing to a lot of entry-level electricians or folks that are aspiring to become electricians, or this is the first time they're getting into the code book. They see this table here and they start to get overwhelmed. But it's really not that complicated. It looks like it, and it's got a lot of wording to it and steps to follow, but once you figure out what their intent is and the process, it actually falls together pretty well. Let's just read what it's about. It says demand factors and loads for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances over 1 3/4 kW rating. And then it says here in parentheses, column C, to be used in all cases except as otherwise permitted in note 3. Okay, we'll come back to that. What you'll see here in this table, you have 3 columns, A, B, and C. You'll notice that I've got this orange highlighter separating A and B from C. One of the key things that people get confused about at first with this table is the differences in these values. In columns A and B, these are all percentages. That's very important to remember that. That's why I have an orange highlighter and I have a note right in the center that I can't miss. These are percentage values. Column C is not. Column C is a kW value. So I have that marked in blue highlighter so I can't miss it. That's a kilowatt value. That makes a big difference because if you are, say you're looking at 20, let's say you're doing multifamily and you're looking at 20 units, and you come over here and you go to column B and you say, oh yeah, 28 kilowatts. Well, no, it wasn't 28 kilowatts, it's 28%. That's a big difference, or it could be a big difference. Or you could go over here and say, oh yeah, 35%. Well, it's not 35%, it's 35 kilowatts. So again, that could make a big difference in your calculation. So you got to remember and be cognizant that we're talking about different values in these columns here. Okay, now back up here to this portion I highlighted here in parentheses. It says column C to be used in all cases except as otherwise permitted in note 3. So the easiest way to use this table is just to go to column C and just use column C. It's very easy, very straightforward. You take, if you have one range, you have 8 kW as your value, as long as that range is not over 12 kW rating. So anything that is 1 3/4, because that's the starting point, 1 3/4 up to 12 kW, you can use column C for that. If you have one range, it's flat out 8 kW. If you have two ranges, flat out 11 kW. If you have, we'll go down here, 25 ranges, flat out 40 is your kW rating. Now, since we're doing single family dwelling, we're only going to be really dealing with the first 2 or 3 for the most part. I mean, you can get more, of course, in larger kitchens, because this isn't, even though it says ranges, and that's a general term used, it's talking about cooking appliances, cooking equipment. So you might have an oven and a cooktop. You might have a range, a wall oven, and a cooktop. So you might have 3 in one kitchen. And so if you had 3 of them, and they're all under 12 kW and over 1 3/4, then you just use 14,000 watts, 14 kW as your unit value. So that is the easiest way to use this table. However, like it says, you have to use column C except as otherwise permitted in note 3. So you're permitted to use note 3's exception. Let's see what it says. Note 3 says over 1 3/4 kW through 8 3/4 kW. All right, in lieu of the method provided in column C, which we just talked about, it shall be permissible to add the nameplate ratings of all household cooking appliances rated more than 1 3/4 kW, but not more than 8 3/4 kW, and multiply the sum by the demand factor specified in column A or column B for the given number of appliances. Where the rating of cooking appliances falls under both column A and column B, the demand factors for each column shall be applied to the appliances for that column and the results added together. So basically, if you have an appliance that falls in this category between 3.5 and 8 3/4, you can use column B. If you have one that lands In this column, which, here's a little side note, this says less than 3.5 kW rating, but what that should really say is between 1 3/4 kW and 3.5, because this table doesn't apply at all to anything under 1 3/4. So I think that's a little bit of a misleading way to word this, because it should say 1 3/4 to 3.5. So if you have an appliance that fell in that range, then you could use column A. So that's what the first part of that says. Now that last sentence there says where you have multiple pieces of equipment and maybe one falls in column A and one falls in column B, then you have to treat those separately and then you can add them together. Now, if it's just one in each, they're both 80%, so it doesn't matter. You can just add them together and take 80%. But let's say you had two of each. You had 2 in column A and 2 in column B. Well, then you would take 75% of the ones in column A and 65% of the ones in column B. Then you add those together, and that gives you your unit total. So, like I said, it's not very complicated, but it takes a few minutes to work through it sometimes until you're really comfortable with the notions here. If you are taking a test, if it asks you for the minimum, which usually what it'll do, it'll ask you for the minimum value for a particular appliance in a given situation, you'll need to go to column A or column B, because that's generally going to give you a lower total than what this will. Column C is kind of the catch-all, and it usually adds a little bit of cushion over what A and B will give you for the same appliance. So keep that in mind, that on a test, if they ask for the minimum, you're going to probably need to use column A or B if your appliance falls in that range. But otherwise, in the real world, if you just go to column C, you're going to be good. That little bit of cushion you build in there is going to be just fine. No one's going to complain about a little cushion. Okay, I'm not going to go over the rest of this table because that mostly is for multifamily, and we're not dealing with that right now. So with a single family dwelling that we're dealing with here, you're going to be up in this first few lines of this table only. Now you may be asking, this says not over 12 kW rating, but what if I have a range or like a double oven or something that's 14 kW? What then? Well, that's what we have note 1 for and note 2. Let's take a look at these real quick. So note 1 says over 12 kW through 27 kW ranges all of the same rating. So if you have a range that's more than 12 kW but not over 27, if you have several even and they're all the same rating, then this is how you apply. It says for ranges individually rated more than 12 kW but not more than 27 kW, the maximum demand in column C shall be increased 5% for each additional kilowatt of rating or major fraction thereof by which the rating of individual ranges exceeds 12 kW. Okay, now it sounds complicated, and it takes a little bit to work this out, but it's actually pretty simple, and I developed an equation for it. And to be honest, it took me a little while to figure out what this equation should be in the most concise form, but this is what it is. And if you apply this equation to anything over 12 kW and under 27 kW, if they're all the same rating, apply this equation and you'll come up with the right answer. And this equation is essentially just these words in the form of a formula. You can see in my notes here, this is the expanded formula here, but then I simplified it, and this is the same thing, it's just simplified. Now, what if they're not all the same rating though? Well, that's what note 2 is for. So now it says anything over 8 3/4 kilowatt through 27 kW of unequal ratings. So for those ranges, an average value of rating shall be calculated by adding together the ratings of all ranges to obtain the total connected load. Then it says using 12 kW for any range rated less than 12 kW, and dividing by the total number of ranges. Then the maximum demand in column C shall be increased 5% for each kilowatt or major fraction thereof by which this average value exceeds 12 kW. Okay, again, sounds very confusing at first, but it's really not that bad. And if you go down here, I have the little shortcut again. It says average all range kWs, but then anything less than 12 kW equals 12 kW. So nothing can be less than 12 kW. That's what this little parenthetical statement is here, using 12 kW for any range rated less than 12 kW. And then after you do that, then you just use formula for note 1. So you use the same formula. So it's actually pretty simple. You average all the ranges, making sure that anything that's less than 12 kW uses the value of 12 kW. And once you get that total, once you average them, then you just plug that into this formula, just like you would if they were all the same rating. Okay, I know that's not probably super clear, but as you process that, as you listen to this, you might have to back it up, listen to it a few times, but you should be able to figure out why that makes sense, why this equation works. And it's just having these little shortcuts here makes it easy, because then instead of having to read through this wording every time, you just take your value you're given, you plug it into the formula, and poof, you get your answer. Okay. So what does that mean for us? Our range in our example was 10,000 watts. If we go up here, we have one range. It's under 12,000. So we just take 8,000. Now, since it's over 8 3/4, we can't use column B because it's 10,000. It's over 8 3/4 kilowatts. So we have to use column C with our range. So we just take the 8,000 kilowatt rating that it gives us and plug it in right there. It's that easy. So if you have one range or one cooking appliance in a dwelling, you can just plug 8,000 in anytime, as long as it's not over 12 kW. Okay, last thing is right here. We didn't read this yet. It says where 2 or more single-phase ranges are supplied by a 3-phase 4-wire feeder or service, the total load shall be calculated on the basis of twice the maximum number connected between any 2 phases. So again, just like the dryer, this is talking about a 3-phase service for a single-phase range or ranges. We're not going to deal with that in this video because that is generally only going to be applying to a multifamily dwelling. And I have another video that discusses that, and I'll go over that in detail when we get there. And then again, there's some examples in Annex D that you can go to help you see how these are put into use, put into practice, these calculations. Okay, so we take our dryer total, our range total, and add them up, and we get our dryer range total for this column, 13,000. Moving on to heating and cooling. We'll start with the heating. So 220.51 says fixed electric space heating. Fixed electric space heating loads shall be calculated at 100% of the total connected load. However, in no case shall a feeder or service load current rating be less than the rating of the largest branch circuit supplied. So all that last sentence means is if your furnace happens to be huge, let's say it's a furnace, and it has to be huge, and your dwelling itself though is really small, to where your service with your demand factors on your service is going to end up being less than 100% of the heating load, then you have to take at least that size, the 100% of your heating, and use it. You have to use the larger of the two, basically. In no case shall the feeder or service load be rated less than the rating of the largest branch circuit supplied. So that's all that's saying. So our fixed electric space heating, that means furnace or ceiling heat or wall heat, baseboards, anything like that, whatever it happens to be, that is your fixed electric space heating. So you have to take 100% of that load. Now there's an exception here. It says where reduced loading of the conductors results from units operating on duty cycle, intermittently, or from all units not operating at the same time, the authority having jurisdiction may grant permission for feeder and service conductors to have an ampacity less than 100%, provided the conductors have an ampacity for the load so determined. I kind of think this should be an informational note instead of an exception, because they're just telling you what may happen. The authority having jurisdiction may grant permission, but really the authority having jurisdiction, they can do that at any point at any time for any code article. They don't have to even adopt the code, so I don't think this should be written as an exception. It should just be an informational note telling you that, hey, your AHJ can kind of do whatever they want and allow whatever they want in regard to this and anything else. I really don't think this even needs to be written here. So it doesn't affect us though. We take our heating at 100%. So right over here, we've got our heater at 100%. And in our case, it was 12,000 watts. Now, we have an AC, or actually a heat pump, at 6,500 watts. But what we're told here in 22060, under non-coincident loads, it says where it is unlikely that two or more non-coincident loads will be used or will be in use simultaneously, it shall be permissible to use only the largest load or loads that will be used at one time for calculating the total load of the feeder or service. Okay, let's stick with that for now. This is what it used to be. This is all this 22060 used to say. This next sentence was not included until the 2020 code. So let's take it as it is first, what we've read. And what it's saying is if you have two loads, no matter what two loads they are, but in this case it's our heater and AC because we have two loads that are not likely to run simultaneously. If it's heating, it's not going to be cooling. If it's cooling, it's not going to be heating. So you can take either of these two loads, whichever is the largest. So in our case, obviously the heater is almost double what the heat pump is. So we will take the largest at 100%, and that is the heater. So 12,000 watts we'll put right there, or VA. Now, here's where it gets a little bit confusing. They added a sentence in the 2020 code, and this sentence has been the brunt of much dispute and argumentation and interpretation because of the way it's worded and what the implications of it are. Let's read it. It says, where a motor is part of the non-coincident load and is not the largest of the non-coincident loads, 125% of the motor load shall be used in the calculation if it is the largest motor. So, where a motor is part of the non-coincident load, which in our case with the heater and AC, we do have motors, and actually both of these loads have motors in them. It says where a motor is part of the non-coincident load and is not the largest of the non-coincident loads, so that would be the heat pump. It has a motor, but it is not the largest of the non-coincident loads. 125% of the motor load shall be used in the calculation if it is the largest motor. So what it's saying is, if our heat pump is the largest motor in the dwelling, which it would be in this case, then this is going to apply. And we would have to take 125% of this value, 6,500, and add it to the 12,000 for our heating total. And that is way far afield from where we've been before in the code. So if that's really what they mean by this, that is a very different approach to these load calculations than we've ever had before. And I don't think that such a departure was the intent of the code panel when they were writing this. My personal opinion is that they meant for this, instead of saying 125%, I think they meant to say 25%. And I think they're trying to capture the extra 25% of the largest motor, even though we're not using it in the calculation, it's still a load on the service. And so they're trying to capture that extra 25% of that largest motor and add it to this number here. That is my feeling on it. I know a lot of other experts also feel that way, but there are some that don't. They read it differently. In fact, I think I've heard 4 different interpretations of this and what the intent of this might be. But that one's the one that makes the most sense to me. And so that's how I've worked up this calculation here. I just took 25% of 6,500 and added it to the 12,000 and got 13,625. Now, we'll come back to this in just a minute, but let's go to this next section because it's very related. and that is the largest motor. Now this is separate from 220/60, but sometimes it is related because they happen to coincide. So I'll tell you what I mean. If we go to Article 220/50, we'll see that it says under motors, it says motor loads shall be calculated in accordance with 430.24, 430.25, and 430.26, and with 440.6 for hermetic refrigerant motor compressors. Now, if we go to those articles, particularly 430.24 and 25, we'll find out that when you have multiple motors, you need to take the largest motor and take an extra 25% of that largest motor. And that's always been the case in all these calculations over the years. We've taken the largest motor in the whole dwelling and taken an extra 25% of that motor load and added it to our load calc. So that's easy. But that's exactly why I think in this case, in 220/60, that's what they meant to do here, and they just didn't quite word it right. They put that one there, and they should not have put the one there. And so that would do exactly what we're talking about. That would take an extra 25% of the largest motor in the dwelling. Even though it happens to not be used in the calculation here because the heater is larger, it's still a load on the service. So I'm thinking that's what their intent was, but I don't know that for sure. And in fact, in the 2023 code, they changed the wording here, but they actually didn't make it any better, in my opinion. They actually muddied the waters even more by the way they worded the 2023 code. So now we're going to have a whole other code cycle with much confusion over this article, this section. So we'll see how the forums go on that with all the debate and again, discussion regarding that section. But anyway, that's how I write it up in these examples, is I just take 25% extra of the heat pump or AC in this case, even though it's not used in the calculation. It is a load on the service, so we're going to take that and add it to the 12,000, which is the largest load, and we're going to come up with 13,625 for our heating total. Okay, so here is everything all filled out for our example. We've got all of our lighting, we've got our total 5520, we've got all our appliances 6,900, we've got our dry and range total 13,000, and we've got our heating and cooling and largest motor figured in at 13,625. Now all we do is we add these four numbers together and we come up with 39,045 volt amps. With that number we can divide by our voltage, which is 240 single phase. We get 163 amps. Now we can size our conductors, our conduit, our meter pack, and all that good stuff. Now here's one last shot of the blank template. Feel free to take a screenshot of it. I took most of the color out of it to make that a little bit easier. Then you can print these up, use them as worksheets, use them in your real world situations or to study for a test. When I was studying back in the 90s, this would have been really handy for me to have. I would have loved something like this. It was much harder to get the information. You had to buy books or take in-person courses. Now it's much easier. There's a lot of YouTube videos out there that are going over calculations, and there's a lot of good ones out there, guys, and be sure to check those out as well. But what I found is there's a lot of discrepancy between how guys approach these calculations, and it's sometimes confusing to figure out exactly what they did and how they got where they got. So what I've been trying to do with this series is make it easy to see. So I go to each code reference and show you exactly where I'm getting all the information for every little step. And so I hope this is helpful to you guys. I really appreciate you guys watching. If you found this video helpful, please like and subscribe. That way it'll be easier for other people to find that are looking for some help with calculations. Please check out my channel. I've got other videos there. I've got more deep dives and a crash course series. And I'll be coming out with other videos as soon as I can, as frequently as possible. I'll be posting them to the channel. And let me know what else you'd like to see, electrically speaking, and I'll see what I can do to get a video made up and posted. And remember, stay free.